I am officially recording right now. There's a second video for the second part of the practice midterm. All right. So we have again duplicated questions to get you ready for each of these. Okay. So again, on this practice midterm, we have duplicated questions so you could have more practice. I'm going to explain one of each. Let's start with this one right here. When you are multiplying two fractions, you want to be able to factor to be able to cancel. That's how you simplify, right? You can't cancel things out if you have addition or subtraction between your terms. Just a quick review here. If you go 3 plus 2 over 5, what am I saying? Over 3, you cannot cancel the 3's. But if you had 3 times 2 over 3, then you could cancel the 3's, right? So you need multiplication in order to be able to cancel things out. You can't cancel when there's addition. You can't cancel those 3's. So again, you want multiplication, and that's why we are factoring. So when you look at these two fractions, let's factor each of them. Let's start with the numerators. Up here, you have an a value of 4, and if you forgot, whenever you have a difference of two perfect square terms, you could do the square root of each and put them in your factored form answer format, which would be a parenthesis, a binomial times a binomial. And how do you do that? You simply take the square root of 4y squared. The square root of 4y squared is 2y, and you write it twice as the first part of each binomial. And then you take the square root of 25, which is 5, and you write that as the second part of each binomial. Now notice that it's not a trinomial. It's only 2 terms, not 3 terms. It's missing the middle term. So in order for the middle term to cancel out, these guys have to be conjugates. In other words, one has to be a plus and one has to be a minus, and it doesn't matter which one's which. I hope we all remember how to factor a difference of two perfect square terms. That's how you do it. Down here, this guy, could you factor anything? Is there a GCF you could pull out? No. Is there a difference of 2 squares? No, it's just, that's what it is. It's a binomial. It's going to stay the same, 3y minus 1. Now, when you look at this one over here, there's nothing to factor. However, it is out of order, right? Normally, we want our y or our x or our variable term first and the constant at the end. Right here, the constant's at the beginning and the variable's at the end. So what we need to do is first rearrange it. And to do that, we're going to take this value and simply write it in front of this positive 1. Okay, so rewriting it, you're going to have a negative 3y out in the front and then a plus 1 second. It's a very important thing that you guys need to be able to do. And then once you organize it with the y term first and the constant at the end, you should recognize that this guy looks very similar to this guy. The only difference is that this is a negative 3y, that's a positive 3y, this is a positive 1, that's a negative 1. So they are exact opposite binomials. So what we're going to do is we are going to factor out a negative 1 to make it look identical. So when you pull out a negative 1 from this guy, in other words, negative 1 times what gets you that negative 3y? Well, that'll be a 3y, okay? And then negative 1 times what will give you a positive 1? Well, a negative 1 times a negative 1 will get you a positive 1. Okay, so we have factored out the GCF of negative 1. Okay, and we only did that because now we have this binomial and that binomial, and we do have that multiplication. So now we are able to cancel those. However, I'm going to hold off on that for a couple of seconds. Now, when we look at this other one, there's nothing to factor here. There's no GCF. So I'm just going to rewrite it. We have a 2y minus 5. And now that we've factored everything possible, we can now cancel things out. Now, if you're thinking, wait a minute, you said you can't cancel if you have addition or subtraction. Yes, but if you treat it like a whole, like that whole binomial, 2y minus 5, could cancel with this whole binomial, 2y minus 5, that completely disappears. You cannot cancel the 2y with the 2y. You know, it's like the whole binomial with the whole binomial, right? And same thing here, this 3y minus 1 and that 3y minus 1, that cancels out. So gone, gone. So what do we have left? We have the binomial 2y plus 5 times that negative 1. Okay. So we're going to distribute it. And notice that there's nothing left on the bottom. So you could put it over 1, but that's kind of a waste of time writing it. Let's just distribute that and that. You're going to end up with a negative 2y and a minus 5. That's your final answer right there for number 7. This is 3 points. I don't know, maybe you factored this one right and you messed up on the other ones, you get 1 point. Maybe you factored that one and this one correctly, you get 2 points, but you messed up on the canceling. If you get everything right, then 3 points. So you have a couple more to practice yourself. And if you're wondering, well, how am I going to check the answer? All you got to do is go to Google Classroom and you'll be able to find that answer right there. As you could see, to double check that one, there it is, that answer. Okie dokie. Moving on, number 8. And there's a couple of number 8s. It's the same concept. Instead of multiplying like we did up here, we are dividing. However, division is the same thing as multiplication. All you have to do is take that division sign and flip it, make it a multiplication sign. When I say flip it, flip that second fraction. So any division problem is really a multiplication problem of the reciprocal of that second fraction. So the first one is going to stay exactly the way it is. However, we might as well start factoring. Now, if you notice, this is a quadratic trinomial with no number in the front. And when there's the a value of 1, when there's no number in the front, it's great because you're going to be able to set this up. Now, it doesn't mean that you're going to be able to guarantee to factor it, but let's try it. What times what is the C value that if you add together is the B value, in this case, +1? And you might want to make a list if you don't remember this. So let's make a list of what times what is -20. So like -1 times 20, or -2 times 10, or -3 doesn't work. -4 times 5, and that's about it, besides changing signs. So now that we made the list of the multiples of -20, let's see which pair of numbers combines together to give us the middle term +1. So if you add these guys, 20 take away 1, that's 19. That's obviously 19. 10 take away 2, that's 8. That's obviously not 8. 5 and -4, that's 1. That's what we want. So this is the correct pair of numbers. You don't have to change any signs. Just put that -4 right there and that +5 right there, and you have factored. Hopefully you remember that. We're going to go through the same process with this bottom one. You're going to think what times what is the C value of -4 that if you combine together is the B value -3. And again, we're going to do the parentheses. We're going to put the X and the X. Why are we able to do that X and X? Because there's no number in the front, right? X times X is X squared. Now, if you had a number out here, you'd have to do a different form of factoring. Anyhow, what times what is -4 that if you add together is -3? You might want to make a list. I'll do it in green over here. How could you get -4? Well, -1 times 4 or -2 times 2. Those are the only two options. And if you add 4 and -1, that'll give you a +3. And you want a -3. So you have the right number 3, you just have the wrong sign, which means you have the right numbers, just the wrong signs. So change that to a +1, change that to a -4, and you'll be good to go. +1, -4. Okay, so we have factored this first fraction. Now, the second fraction, we are going to flip it, okay? So we're gonna take this denominator and write it up here, but as I move it up, I might as well factor whatever I can. The GCF is what? What could I pull out? Yes, a 2. So we're gonna pull out that 2, and on the inside, you're gonna have a x plus 1 left over, because 2 times x takes you back to 2x, 2 times 1 takes you back to 2. And notice this was on the bottom, but now it's on top. Now up here, we have a quadratic trinomial. The a value is 1, which means that we could set this up. As we bring it down, we're going to factor, put the x and the x. And again, we think what times what is a C value of -15, that if you add together is a B value of +2. You might want to make a list. -1 times 15, -3 times 5, and that's it. Now, when you add those numbers, the -1 and 15, that's 14. That doesn't work because that's not a 14. But right here, -3 plus 5, that is a +2. So that's the correct pair of numbers. We want a -3 and a +5. So now that everything's factored, now that we have a bunch of multiplication, now we could cancel out anything that's identical on top and on bottom. So we do have the x minus 4 with the x minus 4. We also have this x plus 5 with that x plus 5. It doesn't have to be directly on top of each other. It could be one on the numerator on the first fraction and the denominator of the second fraction. What else do we have? We also have the x plus 1 down here and the x plus 1 up here. So what does that leave us with? Up on top, we just have a 2, and on the bottom, we still have the x minus 3. So that is your simplified answer of number 8. And of course, you could double check that. Number 8, 2 over x minus 3. That's what we got here. And you have 2 more to practice. Actually, no, just 1 more to practice. And you could check your answer on Google Classroom. Moving on to number 9. Number 9 is a little more challenging because we are adding and subtracting fractions, not multiplying or dividing fractions. Multiplying and dividing is easy because all you got to do is factor and then cancel. But adding and subtracting, you actually need to get a common denominator to be able to add or subtract any fractions. So when you're looking at this denominator, that denominator, and that denominator, what would the common denominator be? What would the LCD be? Any ideas of 5, 2W, and 10W? Anybody? 10W would be the LCD, right? Why? Because 10W is already 10W. You could change this easily to a 10W by multiplying by 5, and you could change this easily to a 10W by multiplying by 2W. So what I like to do is rewrite my 3 fractions, but with the LCD that you guys just said, which was 10W, I'm going to write that at the bottom of each. 10W, 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 and of course, we have a minus sign right here and a plus sign right there. This is how I show my work. So how do I change the 5 to become 10W? I want to multiply by 2W. So I want to multiply by 2W as well. So I end up with the 6W up here. And how do I change the 2W to become 10W? I multiply by 5, I end up with the 5 up here. And how do I change the 10W to become 10W? That's already a 10W, so you don't have to do anything. Just bring down that 5, okay? And from here, all you have to do is add or subtract the numerators, which in this case is pretty simple because the answer is going to be over that LCD 10W. And when you add the 6W minus 5 plus 5, the minus 5 and the plus 5, those guys eliminate. So all you really have left is a 6W up there. Okay. Now, that is your answer. However, whenever you have a fraction that's an answer, always try to simplify it, reduce it, right? And of course, you could cancel out the W's because you don't have addition or subtraction between the 6 and the W or the 10 and the W. The 6/10 reduces down to 3/5 if you divide by 2. So 3/5 is your final answer. Checking your work on the solutions that I gave you, there it is, 3/5. Oh yeah, it's getting more fun. Take a look at number 10. Right here, these are complex rational expressions. We have fractions within fractions. Not only that, we are adding fractions on that numerator. So let's start by focusing in on the numerator. This fraction plus that fraction. Now, in order for you to add or subtract fractions, you need a common denominator. So imagine if you had the denominator 3 and the denominator 2, what would the LCD be of 3 and 2? It would be 6. How do we get that? By actually multiplying them together, right? So right here, you have the binomial x minus y and the binomial x plus y. If you want a common denominator, you could simply multiply them together, okay? So I'm going to rewrite both of these fractions, but instead of writing them with the denominators that they have there, I'm going to write them with the LCD, which is both of them multiplied together, x minus y times x plus y, x minus y times x plus y. Okay, so all I did was put both of those together with multiplication, and I'm not even going to multiply them. I'm just writing them together with multiplication. That is my LCD. Now the question is, how do I change this first fraction, this denominator, the x minus y, how do I change it to a x minus y times x plus y? Obviously, it's missing the times x plus y. So you're going to do that to both top and bottom. So up on top, you get 5x and 5y. So you have 5x plus 5y. And likewise, how do you change the second fraction's denominator x plus y to become x plus y times x minus y? It's obviously missing the x minus y. So you're going to multiply both top and bottom by x minus y. And right here, you distribute 2 times x, that's 2x, and 2 times negative y is negative 2y. So why did we do this? To be able to get common denominators, to be able to add the numerators. Okay, so let's get our final answer for the top. Okay, so here's our fraction, and the final answer for the top is going to be that LCD which is x minus y times x plus y. And when you add the 5x with the 2x, you get 7x. And when you add the 5y with the minus 2y, you get a minus or a plus 3y. So notice this gave us this answer. Here's my division bar. Here's my division bar. So this is my answer on my numerator. Okay. Now let's rewrite this guy at the bottom. So at the bottom, we have this division of the 1 over x minus y. Okay. So you really have a fraction divided by another fraction. Now that's written vertically. It's probably better to write it horizontally. So here it goes. We have a 7x plus 3y over x plus y times x minus y. And we're going to put divided by 1 over x minus y. There's a lot of writing. We're going to end up changing this division to multiplication, but as long as we flip that second fraction. So let's rewrite everything one more time. 7x plus 3y over x plus y, x minus y, over x minus y over 1. Okay, so now that we have pure multiplication, and now that this is factored, you can't factor here, can't factor there, there's nothing else to do. We could cancel out anything that's identical on top and bottom, like the x minus y, that whole binomial with that whole x minus y. So what's our answer going to be? It's going to be 7x plus 3y over x plus y. Keep in mind, you cannot cancel these x's because of the addition, cannot cancel those y's because of the addition. So that is as far as you could simplify this. That is your answer. And on Google Classroom, you're going to be able to verify that answer right there. So you have more practice. And again, you could check your answers on Google Classroom. Let's move on to these next three graphing, these rational functions. So we have 11, first, second, third. They're all the same type of questions. It says identify the asymptotes, the domain and range. It's very important to identify asymptotes. That's how you actually graph these guys, right? So I hope we remember the form of one of these guys. Let me rewrite the form here. We should all remember that the h is always being subtracted from x, either in parentheses or in a square root or in the denominator, right? The h is always being subtracted from x. The k is the number that's being added or subtracted at the very end on the outside. And normally a is out in the front, but when you multiply anything times a fraction, if there's a 1 up here, then you just multiply that a times 1 and you'd end up with your a up on top. It looks like a 9, but there it is, a up on top. So this is the form that we are supposed to memorize. And we should all know that the asymptote, or better said, asymptotes come from the h and k. So the asymptotes, the horizontal asymptote will be y equals y equals k. And the vertical asymptote will be x equals h. So understanding these notes, we should already be able to state the horizontal asymptote. That's going to be y equals 3. That comes from this k value right here. And the h value is 1. So x equals, and you have to think opposite of what you see here. So x equals -1 is your vertical asymptote, right? So that's what we start with. And we're going to actually plot those asymptotes. We're going to graph those asymptotes on the xy plane. So again, the horizontal one, y equals 3. Go to your y-axis, go to 1, 2, 3, and then do your dotted line horizontally. And then you have your x value, x equals -1. That's your vertical asymptote. So go to the x-axis to -1 and draw your dotted line right through there. Okay. Now, the quick sketch would be to recognize that your a value is negative. So that would be behaving, it would end up kind of like a line with a negative slope. It would end up here and down here. So you're going to be using this part of your asymptotes and this part, right? You're going to graph that way. But to be more specific, and even if you didn't want to think about this, what you could do is make a quick XY table and plug in some numbers that are on the left side of your vertical asymptote. Okay, this is like even safer way of graphing. So like your vertical asymptote is at x equals -1. So if you wanted to, you could plug in a -2 and a -3, right? Or any number that's on the left side that would benefit you. So if I did plug in a -2, would that be good? If I plugged in a -2, that would, because -2 plus 1 is -1. Then you'd have -2 divided by -1, which is +2, and +2 plus 3 would be 5. So when I plug in a -2, I get out a +5, and that's an actual coordinate. -1, 2, 1, 2, 3, 4, 5. It would be right here. Okay. Now, if you wanted to plug in like -1, 2, 3, would that work good? I think it would, because when you plug in a -3 plus 1 is -2, -2 on the bottom, -2 divided by -2, +1, +1 plus 3 is 4. So when you plug in a -3, you get out a 4. So you go -1, 2, 3, 1, 2, 3, 4. It would be a dot right here. And just by knowing that, you already know that the graph itself has to infinitely approach the asymptote. And same thing in this direction, infinitely approach the asymptote. So that's that half of your graph. Now, if you wanted to, you can make another XY table to plug in a couple of values on the right side of this vertical asymptote, like 0. Well, if you plugged in a 0 right there, let me actually show that I'm plugging in a 0. When you plug in a 0 right there, 0 plus 1 is 1, -2 divided by 1 is -2, -2 plus 3 is +1. So when you plug in a 0, you get out a +1. So if you go to 0, 1, it would be right there. Again, 0 on the x, 1 on the y, it'd be right on the y-axis itself. Now you could also plug in, like, let's say 1. Let's plug in a 1 as well. 1 plus 1 is 2. -2 divided by 2 is -1. -1 plus 3 is 2. So when you plug in a 1, you get out a 2. And if you went to the coordinate 1, 2, it would be right here. And of course, if you drew a line through there, you know it has to infinitely approach the asymptote. Wait a minute, mess that up. There you go. And that's your perfect graph. Okay. Now this is perfect. Now, yes, you could have just sketched it in the sense that, oh, the a value is negative. That means it has to end up here and down there. So you could just draw it. But if you wanted to be perfect and get some actual x and y values, all you have to do is plug in some x values on the left side of that vertical x value, the vertical asymptote, like -2 and -3, and you get those dots. You could also plug in a couple of values on the right side, like 0 and 1, 0, 0 and 1, and get those two green dots. That way you get perfect graphs. And of course, if you wanted to check that, it's right here in Google Classroom. Can't make that perfect. There it is. Anyway, you get the idea. Last one, last set. So we have finally equations that involve fractions. So one option is to get a common denominator and add and subtract fractions and then worry about getting rid of the fractions. But I like to just get rid of fractions right from the start. So whenever I see a fraction in an equation, if it weren't an equation, you can't do this. But in an equation, if you have a fraction, you want to get rid of it, all you have to do is multiply everything by the denominator of the fraction you want to get rid of. So in this case, you would multiply by the binomial x plus 3, by the binomial x plus 3, binomial x plus 3. That way, the fraction disappears. You end up with just with an x. Now, this next one, you're going to end up with positive x times x, that's a positive x squared. Positive x times 3, that's a positive 3x. Now you still have the equal sign, and over here, these guys cancel out, so you still have the numerator. That's not numerator anymore, it's just a regular 5x plus 6, no more fraction. So what we have here is a quadratic equation. And anytime you have a quadratic equation, I recommend setting it equal to 0. That way you could try to factor it. And if you're able to factor it, change it to multiplication, you're going to then be able to use a zero product property to split it and solve. So let's begin by simplifying this fraction. we could combine the x plus 3x, that'll be 4x. We have an x squared right in front. We have an equal sign of 5x plus 6. Let's move everything to the left side. I'm going to subtract 5x, subtract 5x. We have x squared minus 1x equaling 6. Of course, subtract 6 and subtract 6, and you'll get x squared minus 1x minus 6 equals 0. And now that you have a quadratic trinomial with the a value of 1, now you might be able to factor it, and it's still equal to 0, but then you'd be able to split it and then solve it. So put an x here and an x there, and simply think what times what is the c value, -6, that if you combine together is a b value, -1. You might want to make a list, -1 times 6 or -2 times 3. Those are the only two combos. If you add 6 minus 1, that gives you a 5. That's not a 5. If you go 3, take away 2, that's a 1. That is a 1, but you want it to be a -1. So you have the right number, just the wrong sign, which means you have the right numbers, just the wrong signs. So change that to a +2 and to a -3, and you're good to go. So you have a +2 here and a -3 there. So now we have this quadratic trinomial factored as a binomial times a binomial. Why would we want to factor it? Because when you have something times something equaling 0, the first something could be 0, and the second something could also be 0. And if you solve both of them, you're going to get two answers, x equals -2 and x equals +3. Now, one more final thing to do, especially because it says right here on the instruction solve, we already solved it, it says, and verify any solutions. So we need to double check and make sure that we don't end up with a 0 in the denominator, okay? So if you plugged in that -2, you don't end up with 0 in the denominator. Plug in that 3, you don't end up with 0 in the denominator. So these answers are good to go. If you really wanted to double check and make sure that 100% you have the right answer, you could plug in those values wherever you see an x. Like if you wanted to check this one, you could plug in a -2 there, -2 there, -2 there, -2 right there, -2 right there, and do all that math and see if it actually equals the left side equaling the right side. But right here, just verifying, I would say just check and make sure that you don't end up with a 0 in the denominator, because if it were 0 in the denominator, that would be an extraneous solution. So you double check over here with the solutions that I provide on Google Classroom, we end up with the same answer. So you guys could try that 2 more times and check your answers on Google Classroom. And if you study this, you should be able to ace the midterm that we're starting tomorrow.